Hello everybody, I am Marco Porta from the University of Pavia and I'm going to present a work entitled A Gaze-Based Web Browser with Multiple Methods for Link Selection. My co-authors are Matteo Casarini and Piercarlo Dondi. Web browsing is undoubtedly one of the most common activities that we perform every day for different purposes, and it is very important that everybody can easily access online content, so overcoming physical limitations. In eye-controlled web browsing, link selection is one of the most critical problems, and pointing the right link may be a challenging task, especially when links are small and are located close each other. Thus, it is important to find solutions that allow motor-impaired users to efficiently perform this simple but essential operation through the gaze. Also, page scrolling needs to be considered, but in general, it can be more easily faced. Of course, there are already works focused on gaze-based web browsing, for example, exploiting an ordinary camera, eye trackers like in our proposal, gaze plus voice, and there are also frameworks for creating gaze-responsive applications in the web context. Typical solutions for link selection are the use of ocular gestures, other solutions based on confirmations through buttons, predictive links, magnification techniques, cursor controlled by directional buttons. For page scrolling, the problems are less relevant, and typically the operation is carried out by means of scroll buttons and automatic scroll depending on where the user is looking at. The browser includes 5 different link selection techniques. By link selection, we mean the pointing of the link and also the virtual click on it to load the associated page or web resource. The link selection methods are menu, discrete cursor, progressive zoom, quick zoom, and free pointing. These selection methods are not completely new, but they have never been integrated into a single browser. And this allows users to choose the methods that they like more, but also allows them to choose the most suitable approach depending on the kind of link to be selected. For example, textual links, image links, and so on. But the main purpose of this paper is also to evaluate the performance of the 5 link selection methods. There are also 2 page scrolling alternatives, directional buttons with big scrolls and gaze position with a smooth motion. That means that depending on where the user's gaze is detected, the page is scrolled up or down. The developed gaze-based browser allows to perform the main web surfing operations, and so it has, for example, the back and the forward buttons, the home button, and all the typical controls for a browser. The structure is very simple with big buttons for easy pointing. The system has been implemented in C# using the open source Gecko rendering engine developed by Mozilla and exploited in the Firefox web browser. As I said, 2 scrolling solutions are available. One allows to quickly scroll big portions of the page using 4 directional buttons, those on the right of the interface. But also smooth scrolling is available that occurs when the user looks at the lower or upper edge of the page. There is also an on-screen keyboard that can be used to type addresses or to provide text input to websites. A list of bookmarks can be managed too, where preferred links can be added and removed. Now let's have a look at the 5 methods for link selection. A method is activated by looking at the corresponding button on the left of the browser. Once a link has been selected, the user must explicitly activate a method again to select another link. And this allows the page to be freely explored without the risk of involuntary selections. With the menu method, the user must fixate the desired link for a certain time. Then a sort of big menu is shown that contains the 5 links that are currently visible in the displayed portion of the page and that are the closest to the fixated point. So even if the fixation point was not exactly on the right link, the user can choose the correct one. In this example, we wanted to select the Earth link in the list, and now you can see that the menu is displayed where there is also the Earth link, and by looking at it, the corresponding page is loaded. Also, with the discrete cursor method, the user must initially fixate the desired link, and then after a certain dwell time, a big cursor appears centered on the link that is the closest to the fixated point. In practice, it is a central transparent rectangle surrounded by 4 directional buttons that can be used to move it. Here is an example. As you can see, there is a central square, a central rectangle that is used to point the links. If the link pointed by the cursor is correct, then the user simply fixates it to select it. If the link is wrong, however, the user can look at one of the 4 buttons to move the cursor in the corresponding direction. In this example, we want again to select the Earth link, but the cursor is positioned on the wrong link, and so the user moves it upwards by looking at the upper directional button. The progressive zoom method gradually increases the size of the page to facilitate link pointing. The user must initially fixate the desired link for a certain time, for example 1.7 seconds like in our experiments, and then continue looking at it during the progressive enlargement. Once a maximum zoom is reached, a virtual click is generated at the point the user is observing. Here is an example in which we still want to select the Earth link. And now the corresponding page is loaded. The quick zoom method immediately performs a big page magnification when the user looks at the desired link for a certain time. Then the user has to fixate the link again for a dwell time to select it. In this example, we select as usual the Earth link. With free pointing, if the user's gaze is detected on a specific spot for a certain dwell time, the mouse cursor is moved there. If the cursor is in the right position, then the user can perform a click by means of the click button on the right of the interface. Otherwise, the operation must be repeated until the cursor reaches the right position. In this example, the cursor is successfully placed in the right position immediately to select the Earth link, and so no further operations are needed. We carried out some formal tests Their main purpose was to compare the 5 link selection methods. We involved 33 able-bodied participants and in particular 17 males and 16 females aged between 21 and 70, 34.8 on average. As an eye tracker, we used the Tobii IX. Initially, participants could try each method for 1 minute. In the first test, there were 5 trials, 1 for each method. In each trial, the user had to select 3 links. The 5 start and subsequent pages had similar structures, all from Wikipedia. Of course, everything was randomized. And here is an example for the solar system page. So the 3 links that the user had to select in sequence using a specific link selection method. In a second test, the participant had to select 5 links, one after the other, using each time a specific method. The start page was the Wikipedia page on water. And here is an example. So the user starts with the menu method to select a first link. Then once the target page has been reached, the discrete cursor to select another link. Of course, the links to be selected were given explicitly to the participant, then the progressive zoom, then the quick zoom, and at last free pointing. And once the cursor is in the right position, by clicking the button, the page is loaded. Here are the mean times to correctly select a link. In the results, we have considered the data of test 1 and test 2 together. A repeated measure ANOVA showed that there was a significant effect of the selection method on the time to select a link, even if the time of quick zoom cannot be considered really different from the times of menu and discrete cursor. Menu and quick zoom are the fastest methods, while free pointing is the slowest. These are the mean selection success rates, that is, selections without errors. For free pointing, we distinguish between actual successes, lower part of the bar in the histogram, and partial successes, the upper part. In this case, in the case of free pointing, we considered an error if the tester succeeded in activating the requested link with more than 10 cursor movements, while from 6 to 10 movements it was considered a partial success. In general, we can say that we obtained satisfying results apart from free pointing. At last, ranking. At the end of the tests, participants were asked to rank the 5 methods with values from 1, the worst, to 5, the best. As you can see from the median values, the menu method is the preferred one. Discrete cursor, progressive zoom, quick zoom are at the same level. Free pointing is the most difficult to use and so also the less appreciated. However, in our tests we had only small links. We have to consider that for big image links it may be also useful. To conclude, we have proposed a web browser controlled by means of the gaze that has 5 different methods for link selection. This is because we want the user to be able to select the best or preferred solution in the different situations. According to our experiments, menu, discrete cursor, and quick zoom are the fastest techniques, also characterized by the highest success rates with progressive zoom. Next steps, we will implement more tests, and also possibly we will try to involve motor impaired testers for a better evaluation of our browser. Thank you very much for your attention. The browser and also the source code are freely available for download, so please, if you are interested, visit that web page. Thanks again.